Hey, what's up, people? So, apparently I just proved like this important theorem. Um, it it started in it started in 20. See, is this really recording? Yeah. So it started in 2016 when I gave a lecture to the graduate students at University of Montana, and the lecture, which I'll show you part of. Um, let's get that up here. Uh, hopefully there's no porn on my screen right now. Yeah, I don't think there is any. I mean, private information. So let's see. This, by the way, this is what I'm calling the Halo Proof Benchmark Challenge, and maybe I'll talk about that later. But an automated theorem prover, what it does is it starts with some assumptions, and every white curved arrow is an inference, and it starts at an initial point vertex that's labeled by a well-formed formula, and that's an antecedent, and the inference sends that to some conclusion, and that's a terminus, and so this is called a theorem graph. And so automated theorem proving turns into a graph theory problem. And I don't know much about graph theory problems, but apparently there's there already are ways to solve graph theory problems, like Dijkstra's algorithm. I don't even know what that is, but it's like a something better than brute force. That's the goal. It is to get something better than brute force. And um, I was just chatting with ChatGPT about my lecture, and so oh, I should probably share the screen. Um, yeah, you have no idea what I'm talking about. I didn't share the screen yet. This is enthralling, and I don't use that word often. This is downright enthralling. Like if yeah, so let's share the screen. I just wanted to make sure there's no credit card numbers. It's not like there's any steal. Anyway, all right, that looks good. Let's do that. Okay, cool. All right, that cool. I can live with that. And it's recording. Okay, cool. I'm gonna edit out that word porn. Did I just say anyway, a little unprofessional, but that's all right. No one's gonna kill me, right? Um, so let's see my lecture. I'm not gonna like play the whole thing, but I do have part of it, and I sent it to ChatGPT for analysis. I sent it to I assigned the gender female, but I know it's a robot. I know it may not have, any gender, but so I had to split it into two parts. And I was trying to do it manually with like splitting it to resolve. And it was like painful. I'm like, hey, can you send me some Python script to do this? And it's like, yeah, sure. And like, boom, boom, like two command prompt like entries that like it had to tell me how to get like an encoder FFmpeg, usually I would have one, but whatever. So let's play that. Just part of it, This was exactly almost down to the month 10 years ago. So it's about the subject. So I just today, like 15 minutes ago, proved a theorem. Um, Now ChatGPT is writing it up right now, but I said, boom, 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 and it said, wait a minute, you just proved this theorem, and I'm like, wait a minute, yeah, I did, and like, but yeah, no, it was my ideas, and but it wrote it down though, and it's writing it up right now, like, but it's based on till September 27th. Okay, so, and this was 10 years ago, and like, I looked a little bit different, and um. So let's throw that in the background. No, I want it small. Okay, okay. There we go. I'm getting to the theorem. I'm gonna tell you what it is. 'Cause I don't know what it is yet. Like all I know is it's okay. It's essentially a procedure to enumerate. Now I know I'm stating it wrong, but it's basically it's okay. So basically, it seems like a theory of everything for set theory. And but that's wrong. Like there's an incompleteness term, so so you can't have that exactly. But it's a way of enumerating the theorems. Now the question is, how do you do that? And the little trick that I had was you invert Gödel numbers, and because I knew that that's a one-to-one function um because of the fundamental theorem of arithmetic. So you can invert Gödel numbers into, well, every, every, I just knew that every number, this was like one of the main parts of the proving the theorem. And ChatGPT did not do this part. I don't know if it could have done this part without me. So this is the part that I did was, um, and yeah, my brain's going faster than I can talk. Every whole number that is the target of a Gödel number um, can be inverted into one well-formed formula. Now, a well-formed formula is a grammatically correct statement, like Superman is fast. That's a grammatically correct statement. A grammatically correct statement could be false or true, not neither. Okay, that has to be false or true. In ZSC set theory, a grammatically correct statement, also known as a well-formed formula, is false or true. Now, that's semantics. Now, in syntax, it would be either theorem or its negation is theorem. Um, yeah, so that's weird to see two copies of me at the same time. I wonder if I have the same mannerisms or not. I didn't even realize that, like, yeah, there's two of me right now. See if I look the same. That's kind of creepy. There's like two of me on the screen at the same time. I didn't realize that that would happen. I was like, because I wasn't thinking like that. I mean, either one of them. Um, because it's just math. Um, yes. So I'm talking about the same thing in both images, except that one of them, in one of them, the ideas are 10 years further along. And let's see. So I told ChatGPT, it gave me the idea and it said, it basically left me hanging. It's like, but there's this one problem. And I'm like, oh, well, you could use Gödel numbers. You could invert them. It said, it gave me his problem. And I said, oh, you could solve that by, you could solve that by inverting Gödel numbers. And it said, yes, but not every whole number is the target of a well-formed formula. And I'm like, okay, yeah, you're right. So, we talked about it and, I agreed with it, not that it matters. It's always right. No, it's not always right. It's wrong a lot. So, you have to be careful when you talk to it. Um, let's see what it has said. Yeah, it's on that page now. Yep, that's it. The universal proof horizon. This is it. This is it. Should I delete it? What do you guys think? Should I delete it? Ooh, there's more. Let's see what it said. Oh, it's 41 pages. Okay. That's gonna take a little while to read because I don't read anything. I don't read anything. Like it's hard for me to read. I don't know why, but it is hard for me to read. Maybe maybe it's all the drinking when I was younger. Like I don't know. Like it's like is this even fair? Like I'm like basically I had some ideas, and it threw together a 41-page document. Like now, but the thing is like it could have flaws on like every other line, and like I wouldn't know because I'm not going to read the whole thing. But see, the worst case scenario is I'm going to submit it. Um, well, I mean, that's even if I submit it anywhere. I might not submit it anywhere. Like, I don't know if I care. Like, if anyone finds out like any of this. But like, okay, so it's 41 pages. Okay, and yeah, right now my mind is going faster than my mouth. This is version one. Okay, monograph with mathematical proof, historical art, Matos. Matos is a man. He might be dead now. I have no idea. He's Matos might be one of the most important people in my life. Um, A331536 is a very special number to me. If you can figure out what A331536 means, then you'll know. And the 2016 lecture six, a SIC is a computer. Like a Turing machine. You might have heard of a Turing machine. Well, Turing is the Turing machine as Tennyson is to SIC. So now I didn't invent or discover semi-ideal computers. That was Chaitin, and he did that roughly 40 years ago. I actually talked to him. He's like 70 or 80. Um, and I asked him a question about that paper. It was like the information theoretic limits on formal systems. I think that's what it was called. And he was like, basically, he was like, dude, come at me, bro. Like that paper was 40 years old, man. Like I have no idea what you're talking about. And I'm like, dude, you should remember everything you wrote ever, you know? And no, he like yeah, that was fair. Like he didn't like that paper was like older than I was, so like yeah, I that was fair. So all right, so ALD, I invented those or discovered them. And ALD, um, so you might know an ATP is an automated theorem prover. That how did the paperclip get on the ground? I didn't put it on the ground. The paperclip is in the center of the table. Must have been the cat or the aliens. Um, so, um, ALD, the problem with automatic theorem provers is like when you're trying to, like prove Fermat's last theorem, you might do like billions of cases and all that does is not deny it. That's all that does is and Riemann hypothesis or that it's all that does is not deny it. And that tells you like almost that just doesn't deny it. That just means no, not a counterexample. Like it just means you haven't found a counterexample yet. I mean, it still might mean that it's false. It just means that you haven't proven it false yet. And so, I mean, it's basically useless to when you run out of your budget, let's say you have enough time and hardware resources and and patience to try like a billion cases and you do not get a counterexample, um, then that does say it halts without any counterexamples. Um, then what you need is an ALD. An ALD is an automated logical decider. I don't have one of those up right now, but I discovered an automated logical decider. Um, an automated logical decider is different from what I just told you about, where it tries like a billion cases and like it fails to find a counterexample, so it just has to like give up with no information. It just says like, oh, all of our examples were true, so we don't know if it's not false. That's all we know is we don't know if it's not false. And um, like Riemann's like it's always been confirmed. So we like that's all we know. Like, I mean, that doesn't prove anything. Unfortunately, it doesn't, I mean, it just means like there's a very simple like you might be wondering like why not? We've tried billions of cases. Why doesn't that prove anything? Like, and it doesn't prove anything in math. And why not? Like, well, there's a very simple polynomial. I think yeah, I used to teach pre-calculus, so it's a x squared minus x plus 41. Okay, 41 is a prime number. X squared minus x plus 41. Let's call that f of x. Okay. So f is the name of the function, and what f does is it takes x and it assigns. So you like imagine you have a whole number in your mind, and it takes that whole number and it assigns to it a whole number that is that number squared minus that whole number plus 41. Now you run through that number through that from one up to 41. Each and every motherfucking time it's a prime number. Try it. Use a computer to try it. Plug in 1, f of 1 is prime. F of 2 is prime. F of 3 is prime. F of 4 is prime. F of 27 is prime. F of 39 is prime. Guess what? F of 41 is not prime. Now, think about it. F of 41 cannot be prime because it's 41 squared. So it's a product of two numbers. So it's not prime. And but if you now it's not obvious like why all the other ones are prime, but you have to check all of them. But all the preceding ones are prime. So that's a really good example of a case where you can do a bunch of checking where they're like they all fit a pattern. They're all prime, and then you suddenly have a counter, like something that goes against the grain. So you did all this checking and it fit one pattern, and then boom, it's like not prime anymore. See now, and then that also goes to show that there aren't a whole lot of formulas where the formula gives you the nth prime number, but that's another story. There actually is a formula called Tupper's formula. I think that does give you the nth prime number, but that's like for super nerds. I don't have that memorized. Yeah, Tupper's formula. No. Tupper's formula is the one that's self-referential. I don't remember. There is one that gives you the nth prime number. I didn't realize there was one, but an automatic logic decider will take a conjecture. It won't prove it, but it will tell you theorem, negation is theorem, it's independent or it's a contradiction. But it won't give you a proof. But it's a conjecture settling machine. And it might use legs, agents that are creative. I developed a agent for proving theorems that's called Predator. And I know I realized later that's kind of a creepy um name for anything, but it is predating upon a proof of a theorem, and um you, there's a lot of context in which you might want to find the proof of a theorem. And what's interesting about Predator, though, what makes it different is that it's I I tried to find that there's some way in which it's creative. And instead of what I mean by that is it's not brute force. Okay? That's what I mean. That's all I mean. I don't really mean like, I wrote down like an equation for creativity. I mean like it's not brute force. And like sometimes like a lot of stuff I write down, like I don't totally a lot of times I write stuff down like I'm not with it until I read it 100 times. Um, oh, conjecture settling. Yeah, this is the one. So what's cool about so when it's talking about cross branch reuse, a branch is like one branch is like the automatic language that's probably not wrong, but well, yeah, that's not wrong, but automatic logic d decider is trying to prove it's true. One branch is trying to prove it's false. One branch is trying to prove it's independent, one branch is trying to prove that there's a contradiction. Those branches are all generating lemmas. Okay. Those lemmas are pooling together. They're all using those lemmas. Even if they didn't prove those lemmas, um, that's the idea that I had is that even the ones that are like the one that's doing proving it independent and the one that's proving it true and the one that's proving it's false, all those lemmas are building up. Like I said, like all four branches, those are cross branch reuse. Okay, so these are theorems about that. That's what I'm talking about here. Um, Technically, it's what my AI is talking about, but like this is an interesting debate. It's like we share ideas, the AI and I. So like I tell it like, hey, why don't we have it so that it has a pool of lemmas that it shares, because if it's a lemma, then it's not false, right? But we need to make it so that each lemma is labeled. And then it was like, yeah, each lemma has to be labeled, because yeah, I mean, otherwise it's contrary, but each the lemmas have to be labeled. But um I haven't even looked at my own theorem yet, so I don't know what my theorem says. I know that it has to do with enumerating true statements in ZFC set theory, and that Gödel numbering has to do with taking the number and coming back to the which statement or well-formed formula that came from, and that was my idea, and let's just go to that. Let's see what that says. I haven't even downloaded it yet, so if my browser crashed right now, I would lose it. I don't even have it yet. It'll prove. I probably want the source. Is that everything? Yeah, I want to make sure I can compile the source just just in case, like just in case my browser crashes, and because that would suck. Actually, let me copy it to my drive. Actually, I'm gonna email to like 20 of my different email addresses too. No, I'll do that later. I won't do that now. Um, where is it? Okay. Oh no, now you know my email address. Yeah, send me an email. Say hello. Now you're gonna know my systems. Yeah, automatic logical deciding. That's what I was talking about. Let's put it on the top. All right, put it on the top. Extract. I don't even know where all these files came from. Where did these files come from? I don't even know. Oh, I know. Oh, okay, now I know yeah. I don't know where they all came from though. Where did they all come from? What date? Like, see, I haven't been sleeping for like these dates. What year was this? Oh, there it is. Let's try that again. So they said it was 41 pages. So it's got the PDF already. Let me rename that a little bit. Universal Proof Horizon. Yeah, that sounds cool. I like that. This is Tech Studio. I mean, if you want to use like a good compiler, like I mean that's what I use. I used a different one. I don't even remember what it was called. It was like Child's Play compared to this. Like this actually run. Like guess what? Now it's not. No, it will. See? Yeah. I don't realize if that's a big tech file or not. 43 kilobytes. I don't know. So this is my theorem. Now, is that cool? I like basically I said, write this. I proved it. Well, I told it what to do and it did it. So is it cool? Can I get this published? There is a disclaimer that that says that I did it, it wrote it. There is a disclaimer that says that. So it, I mean, can it be published or not? 'Cause I didn't write it. I didn't write it. I was the one who proved it, but I didn't write it. So, holy shit. Blocking everything. Oh, I should probably compile it, shouldn't I? That's what I am here to do. Probably make this a little smaller. Yeah, I shouldn't use maximized windows. Oh God. Fine motor control. I should not be like a surgeon or a guitarist. It is still compiling, by the way, just in case you're wondering. Yeah, there's a section here called From Gödel Numbers to the Nth Well-Formed Formula. That's a cool idea. I'm eagerly awaiting that one because I mean I only had like a concept. I thought that is a one-to-one function, so it is invertible, but um how's that gonna work? You know? Still compiling. I think it is still compiling. I'm still compiling. That's interesting. Well, I could just open up the PDF, I suppose, but I want to make sure it compiles though, so I do want to do that. Do want to do that, but do I want to do that while I'm here? Let's see. So these guys, the conjecture settlers, yeah. So you'll frequently see in these papers P versus NP. That's because I think like you'll see that more often than like Riemann or the other clay problems because P versus NP. I I mean I think like it's discrete. It's like the it seems like the most likely to avail itself to computing, but it could be completely wrong. I mean, like Stephen Wolfram would probably say that's not true. Um, the integrate command, the derivative command, like different solving differential equations, that all works just fine on a computer algebra system. Even though there's no infinitesimals going on inside a CPU, as far as we know, just electrons, and it's just computing also. Um, so why not? Why can't we do Riemann on six, you know, semi-ideal computers? And so maybe we should be doing, you know, because according to the proof horizon theorem, I mean, maybe we should be doing other theorems as long as you can formulate it in ZFC. Um, why is it still compiling? I'm disturbed by that. It should be finished. Or am I like, did I actually start it? Wait, did I start it? Why is it still going? Well, anyway, I have the PDF. What are these other files? Figures? Okay, what figures are in there? That's my sequence. That's my sequence from the encyclopedia. That's not, that's like logarithmic. Yeah, it is logarithmic. Yeah, I was gonna say that's not how it's supposed to look. Now, in a logarithmic scale, it actually has a pattern. Huh, that's interesting. Okay. Um, what else? Oh, I get rid of these two guys. Let's just go for the PDF. Oh, I guess it finished, well, whatever. Okay. So this is the first draft, version one of like, I guess, oh, it has both master's degrees. Huh. It read my resume. I guess. So table of contents, the universal proof horizon operator. So I know proof horizon has something to do with like how long is it going to take to get proved something proved? Like, so on the horizon, meaning like I don't know if that makes sense, but like the proof horizon, like on the horizon, like when is it going to get proved? Like, are we there yet? Are we there yet? Like that's my general impression of proof horizon, and then universal. It sounds good. Let's enlarge this. All right, let's go through this, see what happens. I'm giving a talk on something that like I don't that it's like totally improvisational, I guess. Oh, automated logical deciders are in here. Okay, cool. Oh, and predators in here. Cool. Um, wow, this is like pretty cool. So MIU was developed by D Douglas Hofstadter in a book about three individuals and their respective art forms. And one of them was Bach, he was music, Escher was art, and Goethe was math. And um, the focus was math. And I haven't read the whole book, but I did read the part about the MIU system, and he wrote it in the 70s. And the MIU system is technically there's a mathematician named Emil Post, I think is his name. Um, I don't remember his first name for sure, but I think it's Post. So it's not Hofstadter who invented like the type of thing that MIU is, but he MIU is more like Post kind of like made a harp, and Hofstadter made a song, and the MIU system is the song. But Hofstadter did not make the harp. Post made the harp, and then like God made strings. Okay, something like that. Like Post did not make um the harp, like either. Like someone else. Say that's where you get closer to what are called formal systems, and that's what I study. Study is formal systems, and an MIU system is more like a musical instrument where you can pluck it and it makes like something that isn't complete noise. I mean, so I mean, if you want to talk about math and music or art, art is art. It could be like um if you got like buckets of paint, you just fucking throw it up against the wall and call that art. Maybe to some people that is art. Who knows? I don't know. If you get a shotgun, if you get a paint gun, it's exactly like a shotgun, like an automatic shotgun that's made of paint, maybe to some people on alien cultures, maybe that is high art to them. There's no telling what. So like in my work, like there's no limits. Like I'm very general, like in terms of like what's called a well-formed formula, any set could be a set of well-formed formulas. Like there's no like everywhere else that I've ever seen, it has to be recursive somehow. There has to be some kind of a pattern, law, like it has to be like a grammar, or something. Well, where I live in my corner of math, like that I study, and again, I might live in the world where in my art, like you maybe where I live, like the artwork of throwing buckets of paint up against the wall is considered high art. I don't know. I mean maybe. Um, I think that's probably closer to the truth is that I'm still studying without limits. I'm still considering that to be something that I'm studying. And I'm not judging like, oh, well, you can't study that as math, or art or music, you know, unless it meets certain criteria. My formal, they're not mine. They're the formal systems that I look at. If you look at the XYZ formal systems, the 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 well-formed formulas, um, there's nothing about them being well-formed. All it has to be is something in the set Y. They just have to be in the set Y. Now, in first order logic, there's rules to being well-formed. So anyway, I talk forever about MIU. I can just start with MIU. So ZFC is standard set theory. Like you can think of ZFC as like mainstream math. You know, MIU is definitely not mainstream math. Douglas Hofstadter did not describe like mainstream math. My guess is that I don't know every mathematician on the planet. I don't know like any. I know like one mathematician. Um, I doubt he's heard of it. You have to have like heard of this book to know about, and you have to have like pretty good knowledge of it. Um, Predator is I mentioned that, or did I mention it? Predator is the automated theorem prover with um the scheme that avoids brute force, and I'll say I avoid the word creativity. And automated logical deciders that has four components, you know, and then it also has like a verifier. A verifier is like the component where it's like, okay, you claim it's true. Well, I'm gonna see if you're right, or if you claim it's a contradiction. We're trying to test if the statement C is a conjecture, like P versus NP. That's like you know going to a distant galaxy from here. Um, or so we think. Maybe it's like one estimate is that it's 10,000 steps of proof away at least. But then I saw another estimate that said that P versus NP is like a lot further than that. So I have no idea. Sorry, this is like one of the coolest things. I, this is like 10 years in the making. I think I deserve some music, don't you? What do you think I'm going to put on? Huh? Wait, when am I going to get my pills? Let's see. So, all right. Oh, wow. Whoa. So it gives us shortest proof. That's, I remember that Neo downloading like Kung Fu. Like when I read Matos's article like 10 years ago or whatever, 8 years ago, 10 years ago, I read Matos's article and I was like, gee, I wonder if there's a way to do that for ZFC. And I said, I tried and I gave up because I was like, oh, well, his formulas wouldn't work because there's infinitely many axioms because there's axiom schemata. Well, I guess I was wrong. Holy shit. This is fucking. I need to print this out, dude. I can't just read this on a screen. Read it on a screen first. Machine learning? How am I going to use machine learning? Who texted me? My Walmart deliveries arrived. How dare they interrupt me? No, I was going to put on music. There's a very specific song that applies to this situation. It's been a while since I've heard it. Too long. Um, it is a time for celebration. You're probably not gonna like it, but it's okay. My delivery would help me right now because it's glasses. One of my new meds is altering my vision. So I'm trying to compensate with with $6 glasses. So in order to do this, I came up with a different way to do automated theorem proving. Proof theory didn't change that much. I thought about shortest proof. I applied Gödel numbering. I am answering a question about ZFC. I'm using an encyclopedia article I wrote about MIU, the OES article A331536. I am using my version of Turing computers called semi-ideal computers. I'm using what I called the proof horizon theorem in my depth of simulation article, which is like 60 pages. Machine learning, apparently. Predator, which is a automated theorem prover, which is not brute force. Automated logical decider, and conjecture settlement. So apparently all that goes into this. Sounds cool, huh? Let's see. Oh, it's blue. Isn't that nice? Dude, whoa, this is crazy. This is like my, this is perfect. Wow. Yep, yep. Audit notes. What does that mean? Audit? Oh, I get it. Okay, audit. Oh, what are the citations? References? What are the references? That first one is my lecture. Now it's gonna have like two more views tomorrow. Yeah, they do make things for this situation. They also make a voice too. But I wanted it to be kind of a surprise. I might just read for a little while without commentary.